Hi, I'm Ashutosh and we are learning chemistry. So this is the final lecture of the chapter carbon and its compound. Okay, I hope that you already watched the previous recordings, okay, recordings of previous lectures. Here in this lecture, we are going to cover these topics. Ethanol, then we will see properties of ethanol, then ethanoic acid, then property of ethanoic acid, and then we will learn about uh, soaps and detergents and how the soaps are going to clean our clothes. Okay, so let's start with the ethanol. Ethanol is has a formula of C2H5 as we can see here. Okay, and it is a colorless liquid having a pleasant smell. Okay, and it is miscible with water in all proportions. Okay, so there is like hydrogen bonding found in water as well as in ethanol. Okay, and that's how they are going to, I can say, miscible, or ethanol is going to soluble in water. Okay, now after this, let's see the properties of ethanol. Properties of ethanol: ethanol is a non-conductor of electricity as it doesn't have any ions. Okay, and it is neutral to litmus. That means that it is not going to behave either acidic or base. Okay, it will be a neutral compound. Okay, now next, uses of ethanol. Ethanol is a very good solvent, okay, very good starting material for many industries. Okay, so as an antifreeze in radiators of vehicles in cold countries. Okay, in countries, what happens, that the temperature is very low. Okay, and when the temperature is very low, so then it is, you can say, a probability, okay, that the fuel is going to be, you can say, have a solidified, or something, okay, like this. So that's how we mix some ethanol, okay, to ensure that the fuel will remain in liquid form. Okay, as a solvent in the manufacture of paints, dyes, medicines, soaps, and synthetic rubber, as I already said, that these ethanols are very good solvent for industrial purposes. Okay, and third, as a solvent to prepare tincture of iodine. Okay, so these are the few uses of ethanol. Apart from these, ethanol is also like majorly used for consumption, and also in laboratories, in you can say, as a fuel. Okay, nowadays ethanol blended petrol is actually used, okay, in vehicles. Okay, so these are about ethanol. Now ethanoic acid. So ethanol, we have just seen that ethanol had a molecular formula of C2H5OH. Okay, and while this ethanoic acid will have a formula of CH3COOH. Okay, it is also called acetic acid. Okay, commonly called as acetic acid. So what is the properties of ethanoic acid? It dissolves in water, alcohol, and ether. So it is going to, you can say, it is soluble in both all the water, alcohols, as well as in ether. It often freezes during winter in cold climate, because when the temperature goes down, so then this ethanoic acid is going to form a dimer. It means that two molecules of ethanoic acid are going to, you can say, combine together. So that's why they are going to form dimer. We can write like this, that 2CH3COOH. Okay, and then we'll get CH3COOH whole twice like this. So this is dimerization. Okay, so it means that dimer formation. So this is called glacial acetic acid, because it looks like a glacier, and that's why this name is glacial acetic acid. Okay, and this was simple acetic acid. Okay, so similarly, we'll have the reactions of ethanoic acid and ethanol. This is a very important reaction. Okay, let's write it. We'll have ethanoic acid, that is CH3COOH, and we have C2H5OH. Okay, wait, we can write like this, C2H5OH. C2H5OH. Okay, so then what are we going to see is H and OH. Okay, will come out as H2O. Okay, and then we'll get CH3, C double bond O, and then O, and then C2H5. Okay, so C2H5 like this. This was, we can say, ethanoic acid. Ethanoic acid. Okay, this is ethanol. And what are we going to get is ethyl ethanoate, which is an ester. A new class of compound, you can say. Okay, and this reaction is known as esterification. Esterification, because ester is formed here. Okay, clear? Next, soaps and detergents. So soaps, what are the soaps? Soaps are sodium salt or potassium salt of long chain fatty acids. So big carbon compound, okay, acid and sodium salt of that acid having cleansing action in water. Detergents are generally ammonium or sulfonate salts of long chain carboxylic acids. So before proceeding further, we are going to watch this video, which is very important. Okay, and we are going to learn few things which are very important for this chapter. Let's watch this.
Carbon and its compounds form an integral part of our lives. From food to medicines, from textiles to laboratories, these organic compounds find a place everywhere. We have seen carbon compounds having magical applications as well. Right from killing microorganisms to cleaning our clothes, they perform numerous amazing tasks. Did I just say cleaning our clothes? Where do organic compounds come into picture for cleaning clothes? Can you guess? That's right, in the form of soaps. Wait, what? Are soaps carbon compounds? Yes, they are. Soaps are chemically the salts of fatty acids. Let's understand this. Fatty acids are extremely long chains of hydrocarbons with carboxylic acid attached at one terminal. Now, since soaps are salts of fatty acids, they have sodium or potassium attached to the chain. So can you guess the structure? Let me help you with that. A long chain of hydrocarbons which can be saturated or unsaturated, and the chain will have a carboxyl terminal and sodium or potassium attached to it. The structure of a typical soap appears somewhat like this. How can they be represented though? Chemically, soaps are represented as RCOONA or RCOOK depending upon whether it has sodium or potassium attached to it. Now it's obvious that these kind of huge structures cannot be written precisely every time. That is the reason why we represent soap molecules using this structure. The ball on top represents the carboxyl terminal with sodium or potassium attached. This end is called the hydrophilic end or the head region. But why is it given such a name? Hydra is water as we know, and philis is loving. That means the end that loves being around or being with water. In contrast, this terminal is called the hydrophobic end or the tail region. Phobia as we know is fear. That means the group that fears being with water. It is the portion that tries being away from water. Hence, this hydrophilic part, which gets attracted towards polar molecules like water, is also referred to as the polar end. And what will this region be called? You guessed it right. It's called the nonpolar end as it gets attracted towards nonpolar molecules like oil, grease, and so on. Now that we know the typical structure of a soap molecule, let's understand how it helps us clean our clothes or vessels. See you in the next video.
Okay, so this was about the shape and structure of soaps. Okay, now we are going to learn that how these soaps are going to clean our clothes. Okay, so when soap is added to water, the soap molecules uniquely orient themselves to form spherical shaped missiles. Let's see this. Let's learn this. So like as it explained that soap molecules are like this or not. This end is, you can say, uh, water loving end. Okay, that is hydrophilic end, while this whole tail is hydrophobic, that is water repelling. They don't like water. Okay, so then what will happen if, let's say, we have a cloth. Okay, we have a cloth here, and then we'll have a, can say, this dirt. Okay, so then what will happen, all these soap ions will come and get collected over here or not. So like there'll be water everywhere here, okay, outside. So the water loving part will be on the outside of this dirt, okay, while the water fearing part will, you can say, hide inside this dirt, okay, because it has a fear from water, and that's why it will try to get like this. Now what will happen, since this water loving part now will get attracted towards water, so water will attract these together, and that's how they are going to come out along with the dirt. Okay, so we are going to have a, like, this situation in which we'll have all these soap molecules arranged in a spherical manner like this. Okay, if you get like this, okay, and this with negative, okay, like this charged part or hydrophilic part outside, okay, and this spherical arrangement is called missile. Okay, so let's, yeah, like this. Okay, so dirt trapped within the soap missile. Okay, next, the non-polar hydrophobic part or tail of the soap molecules attracts the dirt or oil part of the fabric, while the polar hydrophilic part remains attracted to water molecules like this. So all these hydrophilic part will be outside, and the hydrophobic part is inside the dirt. Okay, then the agitation or scrubbing of the fabric helps the missiles to carry the oil or dirt particles and detach them from the fibers of the fabric. Okay, now, so this is how we are going to clean our cloth with the help of these soaps. Okay, now question, would you be able to check if water is hard by using a detergent? Okay, like uh, we know that what are the hard water and what is the soft water. Hard water means that when we are not going to get enough leather form, okay, when we use soap, so then it means that the water is hard. Okay, so it is not possible to check if water is hard by using a detergent, although we can check it with help of soap, because detergents are salts of ammonium and sulfonates of long carbon carboxylic acid. Unlike soap, they do not react with calcium and magnesium to distinguish the nature of water, whether it is hard or soft. Okay, so if we are going to we are going to, you can say, determine the nature of water, that whether it is hard water or a soft water, we will be using soap. Okay, and by use of detergent we cannot determine that whether uh, the given water is hard or soft. Okay, next question, people use a variety of methods to wash cloths. Usually after adding the soap, they beat the clothes on a stone or beat it with a paddle, scrub with a brush, or mixture is agitated in a washing machine. Why is agitation necessary to get clean clothes? Why? Okay, so the answer is agitation is necessary to get clean clothes, as agitation aid soap missiles to trap the oil, grease, or any other impurities that have to be removed. When they are being beaten or agitated, then the particles are removed from the cloth surface and go into the water. thus cleaning the clothes. Okay, so okay, so this is all for this chapter. I hope that you like got all the concepts very well. Okay, and enjoyed learning. Okay, thank you all for your time. Keep watching all the chapter recordings. Okay, keep learning from Ask IITians. Thank you.